Hey everyone. So today is the first day of this thing called computing the square. So if you remember what we were talking about yesterday, we reviewed why the vertex form was so useful and why we're going to focus so much on the vertex form in chapter 4. And if you also remember, I talked about how all of this, right, this big flow chart going from a polynomial function to factor and all the way down to just figure out the vertex. It's a long-winded process. Yes, you get a lot of good information from it. Like, for example, you get your x-intercepts, you find your axis symmetry, you can use this to calculate the y-intercept, and you can also identify the vertex by plugging in the x value. However, it takes a long time. There is a mathematical process that gets you the actual equation, the final equation, just from a polynomial form. And that, I'm just going to call it a shortcut, but it's mathematically heavy. We're going to learn this process today. Instead of doing all of this, if you can just do that. And if you take a look at the sheet in front of you, that is like this, there is a step-by-step procedure of how to go from a standard form, polynomials, to the vertex form, so you can right away figure out what h and k is. That's our goal today. This situation is so mechanically heavy that I know a lot of people will not be willing to put a lot of time and effort into it. It just seems like a lot of work. And so what I'm going to do, being the teacher, I would like you to study it hard in preparation for a very, very small, single-sided, one piece of paper quiz. It's going to have 2 questions on it. One is very straightforward K, and one will be a word problem that's very, very straightforward, no confusions. I give you an equation, I ask you what the max or min is. Okay, this quiz is going to be on Monday. So on the bottom of this sheet, you write down, so all the way on the bottom of the sheet, could you write down this? The writing is too big. Let's do smaller. What I want you to write is, reminder, practice quiz, Friday, April 1st. Real quiz, Monday, April 4th. Have that down. This coming Friday, I'm going to quiz you with the procedure to see if you've either memorized it or if you've written it down on your cheat sheet or whatever. Okay? And then we'll go over it together. I'm not going to give you much time. So you have to be able to spit one out in 5 minutes every single time or something. And then we'll take it up. We'll talk about what you can expect on Monday, and then we'll go on to our next lesson. Please write that in the corner somewhere. We are going to look at the process of completing the square one step at a time. I'm going to try to explain why it's happening the way it is mathematically. I don't think I can explain where the actual steps come from because for a lack of time. But if you are interested, I would be more than happy to explain all of it. Okay. Any questions before we begin? No? No? Okay. So when I start these steps, a lot of it may not make sense. But it's because I'm trying to turn this into this shape, right? X minus some number plus some number. I'm trying to turn this to have a bracket. I'm trying to turn this to have a number in front. I'm trying to turn this into something that is squared, and then a number is at the end. So you'll see me manipulate a lot, but try to bear with me. Okay? Everyone ready? Everyone's okay? Let's take a look at what this is. Step 1, take your polynomial and group the first two together. So I'm going to put the first two inside a bracket and leave this third term, this constant term, off on the side. And it looks like this. So I want you to write y is equal to big bracket plus 11. Group the first two together. And if you want to use highlighters, I invite you to do so. Your bracket's going to look like 2x squared plus 12x. Just to show you where all the numbers are going. Okay. Question so far. Every single time I do something, I need you to ask yourself, does that equal the previous line? Because I can't change anything without making sure that it's mathematically legal. Each line has to be equal to the previous line so that when I write my final line, this equation, whatever that is, must equal this. You get what I'm saying? If this line equals this, and this line equals that, and this line equals this, and this line equals that, and this line equals this, blah, 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 then the final line must be able to backtrack and say, oh, it equals the top line. I need to get there. Okay? So please always ask yourself, does that make sense? Step 2, do you see this bracket? Please common factor just the coefficient, not the x, just common factor the coefficient. In other words, divide out the 2. So 2 divided by 2 is 1, 12 divided by 2 is 6. I will again, yep. The goal of this process is to try to make this look like that. So I'm not actually trying to just factor. I'm doing selective factoring for a specific goal. So so step 2 is just factor out the a value, not the x itself. Yep. Watch how it progresses, watch how it changes, because I'm trying to manipulate something right now with a purpose. It's not just, again, it's not just factoring. Okay. So again, every time I write a line, does it look like the previous line? Can I mathematically say that these two are equal? I think so. Next, here's a funny part. Find the perfect number that completes the bracket and turns it into a trinomial. What do I mean by that? I need the bracket to be a perfect square because I have goals to turn this into two binomials that are equal. In other words, I need a number that will take these two and turn it into a perfect square trinomial. How do I find that number? This is really important. Take the 6. I would like you to divide by 2, then square it. Divide it by 2 and then square. So 6, divide that by 2 is a 3. Square the 3 is a 9. I want you to add a 9. I know that sounds really weird. Whatever that middle number is, divide by 2 and then square it. But right now, mathematically, can you say that this line is the same as the top line? No. So I did something illegal. So to make sure that it is legal, look at this silly thing I'm going to do. Well, if I added 9, all I have to do is subtract 9. What about that? would you say that this is now mathematically legal? Would you say that this line and that line are equal to each other? I added a 9 and subtracted by 9. It technically, I added a 0, right? So yeah, that's how I'm going to justify my actions. This is why. So for the people here who've been really working on their factoring, you might see this to be a nice trinomial. So step 5, this is the hard part. Put little stars next to it and say it's hard. I want just this trinomial. Because if I have a trinomial, I can factor it. What happens to the negative 9? Well, I am going to remove it and bring it to the outside. Look what I wrote. I'm going to pause right there, giving you an opportunity to think about it. Why the heck did it turn into a negative 18? You see it? Didn't? If that negative 9 comes out of the bracket, it actually equals a negative 18 because the entire bracket is right now multiplied by a 2. Think about it this way. If I had this and I decide to expand it, without the bracket, it will be 2x squared, 12x, plus 18, and minus 18. What I'm taking out is actually a negative 18. So please be careful. If there is an a value, the number you are removing from the other trinomial has to be multiplied by that 2. So I'll put a little highlight there to remind you that that's where it came from. Maria? You got a hand up? Nope. Okay. All that's left is to factor and to simplify. So y is now this. So negative 18 plus an 11, I'll do that for you. That's simple enough. I am going to factor this. 2 numbers that will multiply to a 9, but add to 6. I'll give you a hint. You already found that number here. What was that number again? That middle number, you divide by 2. That's the number that's going to come up here. So what's the final answer? 2x plus 3 squared minus 7. I'm running out of space, but I want to keep all this here on the screen, so I'll write it here. H equals a negative 3. K is a negative 7. Therefore, my vertex is negative 3, negative 7. Look at it. I just found H and my K. Right? I turned this polynomial into vertex form. Now there's a lot of annoying steps, and every single one of these will be unfamiliar to you right now. But that's the entire lesson today. I'm going to turn the page and get you to try with me some of these other examples. We'll practice and we'll practice and we'll practice in preparation for the quiz. Tomorrow we'll practice some more, but this time I might throw some word questions at you to show you that it's exactly the same procedure, but you have to talk about the vertex after. So this is the actual, this is the procedure. This is what it means to complete the square. And why do you complete the square? You want to go from a regular standard form, ax squared bx plus c, and you want to turn it into the vertex form. That's the whole goal of this. The rest is just practice. Shall we? If you are ready, please turn to the back page. We'll do some homework questions together. Maybe do a couple to make sure that you know you're on the right track. Yeah. But on the back page, this is from the textbook, question 6A. Let's try it. Here. Down. All right, 6A. My function is x squared plus 8x plus 3. Great. Welcome. First step. Yep, go through the motions, look at the sheets. Look at the sheet in front of you. What did we do as our first step to manipulate this function? What did we do? Now, this is very mechanically heavy, right? Step 1. Yep. Right. You just get rid of that third one. I don't like it. The main reason is this 18, x squared plus 8x plus 3. No, that's not going to be factored nicely. I want a number that factors nicely. I don't like that 3. So I literally just remove the 3 away. I'm going to change the 3. I'm going to put in a number that I like. That's completing the square. All right. What's next? Huh? Not yet. I need a trinomial. How do I get that third number? What did we do to get that third number? Take that middle number, divide by 2 and square. And I think you can try that in your head. 8 divided by 2, square it. 16. But I did something illegal. I just added out of thin air. So how do I justify that? Charlie? Oh, sorry. I'm sort of jumping the gun a little bit because I see. Yes, in the first example that we did in the front page, I first factored out the a value. Okay. Right now, there is no a value. It's just a 1. So even if I divide out a 1, I'm left with the same stuff inside. So we're done that step. Next, if I want a perfect square, I am going to take that 8 divided by 2 and square, which is plus 16. But of course, I can't just do that out of thin air. If I add a 16, I'm going to have to subtract by the same number. Yes. Correct. What? In this case? You're right. So you could factor out a 1, which doesn't change the values. Right? So essentially, for this question, we can sort of skip step 2, the factoring out of the a, because it's a change in it. Next, now that I have plus 16 minus 16, I really like this trinomial because I know it's going to be a perfect square. I need to get rid of the negative 16. I literally remove it from the bracket, multiplying with the 1. So this bracket, this trinomial remains as x squared plus 8x plus 16. Negative 16 is multiplying with the 1, leaving me with this. All that's left is to factor. So we have x numbers that add to 8 and multiply to 16. Again, you found that number here already. 8 divided by 2, that's a +4 and +4. The vertex form for 6a is so again, this technique is very mechanically heavy. And ultimately, you're going to probably approach this in 2 ways. Practice your butt off so that these steps become very natural to you without thinking. You're like, okay, I know what the next one is. Okay, I know what the next one is. Okay, I know what the next one is. Or you're probably going to copy these steps word for word in your study sheet and bring that to your quiz or your test. I would like you to maybe do both. Practice so hard that you don't have to look at your study sheet every single time for every single step. But still have it there to remind you in case you do forget. Okay, shall we try maybe a more challenging one? Not B. Let's do, I don't know, D, E, or F is hard, but D or E or F. Let's try that together before I get you to do the rest. Any preference? Take a look at the questions from the homework. D, E, or F. Choose one. What looks hard? Let's do D. D. F of x equals -x squared plus 6x plus 7. Step 1. Who did step 1 for me? Brendan, you did step 1 for me. Perfect. Yes, we're getting rid of that third term because we don't like it. It doesn't give us a perfect square. Charlie, I think we were talking about step 2, right? You were confused before. I think it's because you caught this one. Right. Before that, though, I think the question you were asking is where did the A value go? Was that you or was that Maria? Maybe it was Maria. My bad. See, I can't remember anything right now. Maria mentioned something about where's the A value, correct? Last question. So in this case, my A value is a -1. So let's get that out of there. Let's factor it out. So -1 divided by a -1 is +1. 6 divided by a -1 is -6. Ready? Oh, right, like I am factoring out, I'm dividing out a -1 from everything. So this negative becomes positive, that positive became negative. And then Charlie's got this one. And then square it. So -6 divided by a 2 is a -3, but -3 times -3. Is everyone okay if I join step 3 and step 4 and just write +9 -9? So like automatically? That's okay. Then I like the trinomial. I don't like that 4th term. What does that turn into? It's not a -9, it's a +9. Yeah. So if I factor this and I simplify this, it will be x and x. What number adds to -6 but multiplies to 9? You already found it. The 6, -6 when you divide it by 2. Negative and negative. There you go. So I'll simplify. Because these two binomials are identical, I can write it as a square. My vertex is 3, 16. I'm going to pause this video and see if you can approach E on your own. And then we'll take it up as our final example. Before I forget, I would like you to, on your own, see if you can attempt 6. F is particularly hard because you're going to end up with a fraction. So if you want to avoid that for now, you can. That fraction also appears once again for number 9. But if you can focus on number 6 and number 8, that will be amazing. You're in an amazing spot if you can do these two just for homework right now. We will look at the word question. Right currently, see if you can solve a letter E on your own. Pause this video. In retrospect, I'm actually happy that I accidentally gave you E because it is a little challenging, but I hope that you'll be okay with it, even if it does fractions. I see a lot of people working with decimals. That's okay, because, you know, at least in this class, I won't give you crazy fractions or crazy decimals that's like 1.3333 repeating, right? It's a nice decimal, but if you choose to keep fractions, I want you to know that it's still very nice. It still looks nice. Okay, step 1, I am going to get rid of the -2 because that does not give me a nice perfect square trinomial. Next step, I'm going to make sure the x squared does not have any other coefficients besides a 2. I'm going to factor out the -1. Next step, I am going to take this, divide by 2, and then square it. Dividing by 2 and square. So let me do this on the side. -3 divided by 2 is -3/2. Some of you wrote it as -1.5. That's okay. If I square that, -3 times -3 is a 9. 2 times 2 is a 4. 9/4. Some of you wrote that as 2.25, and that's okay too. I'm going to keep it as that. Look at that. I think you're probably already getting used to skipping a step. That's really good. You're doing both at the same time. Something that's taking 7 steps, now you're doing it in 6. Great. If you can start doing 6 steps and start doing it in 5, amazing too. Next, I know that
we are going to be testing the sound in the hallways, not in the classrooms, for the next few minutes. So please be patient. Thank you.
I also know, again, it might look weird, but you and I know that the first 3 terms of this quadnomial, right, this polynomial is what I like. I want to get rid of the 4th one. And when I do, it has to multiply with the -1 in front of the bracket, leaving me with that. So I'm going to factor this. And I already know what these numbers are. Remember, I already found it here. It's this number divided by 2. It is -3/2 and -3/2. And this, you can use your calculator, you can use decimals. It's going to turn into a +1/4 or a +0.25, whatever works for you. My final vertex form is that. Now let's be consistent. I'm going to do 1/4. So even if it looks complicated and you get fractions, don't be afraid of the fractions. Okay, number 1 and number 2. Yes?
Could we do that after?
Sure. That one's like even more annoying, right? Yes.
Decimal with the in the bracket.
It'll be -1.5. So x -1.5 squared plus 0.25. Okay. Yeah. So again, here's a request. Can we just quickly do F absolutely. It's going to be even more annoying because when I divide the 2 out, it's going to leave you with a fraction inside. I will do it both in a fraction way and in a decimal way, just to show you that they're both possible. And if you could, I would love you to try the fraction, leaving it as a fraction. So anyways, those are my, hopes as a teacher. Yes, Charlie? Nope, I won't take off marks. I understand. Okay, I'm gonna do step 1 and step 2 and step 3 at the same time. Now that you've had so much practice, take a look to see if you can keep up with what I'm doing. Did you see what I did in one step? I removed the third term and I factored out the 2 at the same time. If you don't like it, try step 2 and then try step 1 and step 2. Next. Ooh, divide by 2 and square. Let me do that off on the side, okay? All right, 3 over 2 divided by 2 is like saying 3 over 2 times 1 over 2. I get 3 over 4. 3 over 4 squared gives me 9 over 16. I'm adding and subtracting 9 over 16. If you don't like that, note that 3 over 2 is 1.5. So 1.5 divided by 2 is 0.75. 0.75 squared is going to be something I can't do in my head. Let's see. Where's my calculator? 0.5625. You see why mathematicians might prefer fractions over decimals? Decimals can go on forever. Okay, next. I like the first 3 terms. I do not want the last term there. So when I remove it, that's great, but I have to multiply by a 2. That gives me negative 9 over 8 plus 1, or that's correct, right? Yeah, 9 over 8 plus 1, or if you want to do 0.5625, multiply that by 2, you should get 1.125. So that becomes negative 1.125. Lastly, I am going to factor this. This becomes 4 minus 1 over 8. Or if you get all of this by decimals, you should get there. You did it all by decimals. Does that work? It's long, Cameron, it is long, but the steps are all going to be the same. Questions?
Why does it turn to negative 9 over 8?
Oh, 9 over, so negative 9 over 16 was being removed, right?
Oh, wait, yeah, we can put a plus. Oh, wait, because I was, okay, never mind.
See, I'm not sure what you're referring to, but
No,
does that answer your question?
Okay.
Okay, perfect. And that's it. Okay, I'm just about ready to stop the video. Your homework, please, just to, again, don't forget the mechanics. Obviously, this is step 1, step 2, step 3, whatever. So it's very mechanical. You need practice. It's not just something you just understand. You got to try it. I'll do number 6. And if you can create all of this in vertex form and solve all the questions from number 8, you're in an amazing spot. Yes, Aisha? Yeah, absolutely. It's actually almost, it's pretty much time to go. Class is almost over. So if you actually want to just wait just 2 minutes and if you want to watch.